Good morning, students. So today, atomic structure assignment. See the question number 1. Lambda naught is threshold wavelength of a metal for photoelectric emission. If a metal exposed to light of wavelength lambda, the velocity is ejected electron will be, they given this one velocity. Then what is k here? See here, they given lambda naught value, threshold wavelength, and wavelength of incident light lambda. And they give the velocity of ejected electron, this one. But here what is their k value? See here, this is the formula for photoelectric effect. This is total energy is equal to W plus Ka. So here E is equal to Hc by lambda, here Hc naught by lambda, K is equal to half mv square. Then Hc lambda is comes to this one side, Hc lambda minus Hc by lambda naught is equal to half mv square. Then here Hc value common value 1 by lambda minus 1 by lambda naught half mv square. Then here 2 is comes to this one side 2Hc. This 2 is comes to this one side 2Hc. Again this m is becomes to denominator value. Then 2Hc by m into 1 by lambda minus 1 by lambda naught is equal to v square. Then v is equal to under root of 2Hc by m 1 by lambda minus 1 by lambda naught. Then v is equal to 2Hc by lambda into lambda naught minus lambda by lambda naught into lambda. So this is the cross multiplication. Then we get this value. Again this value we can write like this. V is equal to 1 by root. Here this value we can write like this. V is equal to under root of 2H by m lambda naught minus lambda into the remaining C by lambda naught into lambda. So this is we can write. So this formula we can write like this. Here this is C, this is lambda naught, we are separating here. But in a question, velocity what they given? Velocity V is equal to under root of 2H by m into lambda naught minus lambda into k they given. Here what is k? K is nothing but C by lambda naught into lambda. That's why here k value is equal to C by lambda naught into lambda. So this is the answer for this question. So option is C by lambda naught into lambda. So option is C. So this is the option for that question. The next one is see the question number 2. The kinetic energy of electron is E. This is the kinetic energy when the wavelength of incident radiation is lambda. Increase kinetic energy of electron is 2E. Incident wavelength will be. They given kinetic energy. At this kinetic energy, incident radiation is lambda. If kinetic energy increases to 2E, then incident wavelength what happen? See here. So this is the total energy is divided into work function plus kinetic energy. Then here kinetic energy is E value we have to substitute here. K is in place of Ka we have to write E. Okay. Then Hc by lambda is equal to W plus E. Then this is kinetic energy is increases here. Here kinetic energy becomes E to 2E. So that's why if it is changed to, if kinetic energy is taken as E based on the problem, then Hc by lambda, this plus E becomes to this side, when it comes to this one side it becomes to minus E. Plus C becomes to minus E. Hc by lambda minus E is equal to W. Here also plus 2E comes to this one side, it becomes to minus E, minus 2E. Hc by lambda naught minus 2e is equal to W. Then equation 1/2, then W is cancelled. Here that's why its value is 1. Sc by lambda minus e divided by Sc by lambda naught minus 2e. Then it is multiplied with this one side. Then Sc by lambda minus e is equal to Sc by lambda naught minus 2e. Sc by lambda minus e equal to Sc by lambda naught minus 2e. Then next one is this minus e minus 2e is comes to this one side. Then we obtain the plus 2e. Plus 2e minus e. Then total value plus e. Then Sc by lambda plus e is equal to Sc by lambda naught. Again this plus e is cross multiplied with Sc by lambda. Then what happen? E lambda plus Sc by lambda is equal to Sc by lambda naught. Then we find out the lambda naught wavelength. The incident wavelength lambda naught is equal to, here also Sc by Sc into lambda, Sc by lambda divided by E lambda plus Sc. So this is the, when kinetic energy is increased from E to 2E, then wavelength is wavelength changed to Sc by lambda divided by E lambda plus Sc. So this is the correct option. Then see the option Hc by lambda. The change in wavelength lambda naught is equal to Sc by lambda divided by E lambda plus Hc. Then see the question. Sc by lambda divided by E lambda plus Sc. So that is the answer for that question. The next one is question number 3. If velocity of third Bohr orbit of hydrogen atom is v, here velocity of third Bohr orbit of hydrogen atom v centimeter second inverse. The number of revolution per second around the nucleus in the orbit approximately. So we have to find out the number of revolution per second around the nucleus. So direct formula is there, number of revolution per second formula. Here number of revolution per second formula, velocity by circumference. This is the formula, velocity by circumference. Here velocity what they given, v centimeter second inverse by 2 pi r circumference. Again v by 2 pi into r value means radius of third orbit na 0.529 into 10 power minus 8 into n square centimeters. So here r value for here n square is nothing but radius of third Bohr orbit na. Then 3 square you have to write here. 3 square means 9. Here I gave already 9. Okay, radius of third Bohr orbit into 10 power minus 8 centimeters. Here pi value is 3.14. Therefore v divided by 2 into 3.14 into 0.529 into 9. Its total value 30. Means 29.99 will come. It means 30 into 10 power minus 8. Okay, here point change it to your 1 digit this one side. So your point change it to your 1 digit, then decrease it 1 digit, then what happen here, 10 power minus 8 is becomes to minus 7. Therefore the number of revolution per second is equal to per second in third Bohr orbit is v by 3 into 10 power minus 7 centimeters per second. Yes, the option is v by 3 into 10 power minus 7 centimeter per second. So this is the number of revolution per second. The next one question is electronic energy of the ground state of hydrogen atom is. This is ground state of hydrogen atom. They given joule mole inverse. We have to convert the energy into joule per atom. Like that, if energy of 9.84 into 10 power minus 5 joule mole inverse, here also they given. Here also joule per mole we have to convert it into, this is the mole inverse. Joule for mole inverse. This is also converted into joule per atom. Is added to the hydrogen atom in the ground state. Then electron get excited to the First of all, this energy changed into joule per atom. Here they given joule mole inverse, we have to convert into the joule per atom. Later we find out the how much amount of this energy is used to exit the electron from which orbit to which orbit. Then see the here energy of ground state minus 1.313 into 10 power minus 6 joule per mole. So here this is 1 mole atoms they given energy. For 1 atom the energy is minus 1.313 10 power minus 6 divided by 6.023 into 10 power 23. That is for 1 atom. Then we calculate that value, we get energy for joule per atom minus 0.217 into 10 power minus 17. It becomes to your point change it here 1 digit to, therefore then we get the E is equal to 2.179 or it becomes 2.18 into 10 power minus 18 joule per atom. So here they given a joule mole inverse energy convert into the joule per atom. That is the energy of ground state orbit. The next one is extra 9.84 into 10 power 5 joule per mole energy is added to the ground state orbit. Then electron jump from one orbit to another orbit. So this is the extra adding electron 9.84 into 10 power 5 joule per mole. So here also joule per mole atom we had converted into joule per mole converted into the here also the extra energy joule per mole is converted into the joule per atom. Here 9.84 into 10 power 5 divided by 6.023 10 power 23. Then we calculate that value. This is total energy per 1 mole, joule per 1 mole. That is changed to joule per atom. Then 9.84 into 10 power 5 divided by 6.023 10 power 23. Then lambda E is equal to, then we calculate that value. We get 1.634 into 10 power minus 18 joule per atom. So this much amount of energy is added to the electron present in the ground state. Then lambda naught is equal to E naught minus E1. Here lambda naught means how much amount of energy is added, change in energy. This is change in energy 1.634 into 10 power 8 joule per atom. That is change in energy is equal to En. En means we don't know that En value. That means here electron is it may be jump to the second orbit or it may be jump to the third orbit, we don't know. That is we have to find out. That is En or Ef. Take anyone. Then minus E1 means we calculate already. That is 2.18 into 10 power minus 18 joule. Then Ef or En. Then En is separating this one side. Then is plus 2.18 into 10 power minus 8. It comes to this one side, it becomes to minus. Then 1.634 minus 2.18 into 10 power 18 minus 18 common value. Then the difference is minus 0. Here minus value. Because of this is higher value, this is lower value. Minus 0.545 into 10 power 8 minus 18. Then En is equal to, formula we know already, energy of nth orbit formula minus 2.18 into 10 power minus 18 by n square. Then En value we find out here just now, minus 0, this is En value. Then what is the En value? Minus 0.545 into 10 power minus 8 minus 2.18 into 10 power minus 8 divided by n square. Then n square separate here. If you separate n square, it is values comes to here denominator. Minus cancel. 2.18 divided by 0.545. 4 times cancel. Here 10 power minus 8 cancel. Therefore n square is equal to 4. N is equal to under root of 4 is equal to 2 value. That means by using this much amount of energy, the electron jump from this is electron present in the ground state or first orbit. This is second or third. By this here ground state energy is minus 2.18 into 10 power minus 19 joule. Excited state energy, excited state that means second orbit energy is minus 0.545 into 10 power minus 8. So here this is excited state electron. This is, but here this is extra amount of energy is 1 point extra amount of energy is here whatever 1.634 into 10 power minus 18. By using this extra energy, the ground state electron jump from the ground state to second orbit, or ground state to here first orbit or second orbit. That's why by using this energy, electron jump from, it may be present in the first orbit or it may be jump to the second orbit. That's where both by using the 9.84 in 10 power 5 joule per mole. Here I gave joule per atom. Its actual joule per mole energy is 9.84 into 10 power 5 joule per mole. So by using this amount of energy, the electron jump from first orbit to second orbit, or first, or it may present in the first orbit. That's why here answer is it may be jump from both first excited state or second orbit. Both are first excited statement ground state. This is n value, this is nt value. First excited state anna or second orbit anna, both are same. That's why option is both 2 and 3. So this is the fourth question answer. The next one is the fifth one question. The distance of separation between the second and third orbit of hydrogen atom. Is here distance separation between second and third Bohr orbit. First of all, we have to know about the radius of third Bohr orbit and radius of second Bohr orbit. Later their difference, that is distance. Then see here this is the radius of orbit formula. What is the radius of orbit? 0.529 into n square by z angstrom units. If it is second orbit, 0.529 into 2 square means 4. Then we get second orbit radius 2.116 angstrom units. The next one is third Bohr orbit. 0.529 into 3 square, n square means 3 square means 9. Then R3 radius of third Bohr orbit is 4.761 angstrom units. This is radius of third Bohr orbit. This is radius of second Bohr orbit. Then distance of separation between the second third Bohr orbit means third Bohr orbit minus second Bohr orbit. That is third Bohr orbit 4.761 minus second Bohr orbit 2.116 angstrom. The difference is 2.645 angstrom units. 2.645, that is answer. 2.645, that is the difference between the third and second Bohr orbit. That means this is first Bohr orbit, second third Bohr orbit. First Bohr orbit we know 0.529 angstrom. Second Bohr orbit 2.116. Third Bohr orbit 4.761. So this is third, this is second. Their difference means how much difference? 4.716 minus 2.116. 4.761 minus 2.116. Its difference is what is that? 2. This is the difference, 2.645. Option is 2.64 angstrom units. Here they given 2.4, that is wrong. 2.64. That is 2.64 angstrom units. So option is 1. The next one is question number 6. In a transition of electron in an atom, its kinetic energy changes from Y to Y by 4. Transition of electron in the atom, its kinetic energy changes from Y to Y by 4. The change in potential energy will be, they given kinetic energy change Y to Y by 4, but potential energy is how much it is changes. Then see here, Here, this is the potential energy is equal to minus 2 into kinetic energy formula. Potential energy is equal to minus 2 into kinetic energy. Here, potential energy is equal to minus 2 into kinetic energy is changes from y, starting y, after then y by 4. This is second one. Potential energy is equal to minus 2 into y. Potential energy is equal to minus 2 into y by 4. This is normal potential energy. This is change in potential energy. So this is normal kinetic energy. This is change in kinetic energy y by 4. Then change in potential energy. If kinetic energy changes from y to y by 4, potential energy is how much it is changes. That is change in potential energy is difference. So here minus equation 1 is subtract from the equation 2. That is the difference between the change in potential energy. Minus 2y by 4. This is minus 2y by 4. Minus 2y by 4. Minus of 2y. Minus of 2y. Here minus of 2y. Minus into minus plus 2y. Then here 2 1 are 2 4 2 2 are 1 by 2 means y by 2 plus 2y. Then we get the we do the cross multiplication. Then 2 into 2y, 4y minus y divided by 2. 4y minus y divided by means plus 3y plus 3y2. 3y divided by 2. So this is the change in potential energy is plus 3y divided by 2. That is change in potential energy. Plus 3 by 2y or 3y divided by 2. Option is 4. Then say the question number 7. The wavelength of series limit of Paschen series of hydrogen spectrum. Series limit means here you have to remember. Series limit means already I told Lyman series N1 value is 1. Lyman series ki 1. Balmer series 2. Paschen series 3. Bracket series 4. P fund series 5. N2 value is here H alpha line 2, H beta line 3, H gamma line 4, H delta line 5. The last one is H alpha. H alpha means infinity distance. Infinity distance is the limiting line. That is the limiting line. So like that here also Paschen series limiting line is infinity distance. It is not 4, 5, 6, 7. It is infinity distance. Means N1 value is 3, N2 value is infinity distance we have to take in that formula. Then only we will get a limiting of Paschen series of hydrogen spectrum wavelength. You see here formula is mu bar is equal to 109677 1 by n1 square minus 1 by n2 square centimeter moles. Mu bar equal to 109677 into 1 by here. Just now I told n1 value is 3 Paschen series. N2 value is infinity distance. 1 by 3 square minus 1 by infinity square. 1 by infinity square means 0. Then 109677 into 1 by 9. Its total value mu bar is equal to 12186.33. Then mu bar is equal to 1 by lambda formula. Because of we have to find out the wavelength, not wave number. The wavelength lambda is equal to 1 by mu bar. Then lambda is equal to 1 by its mu bar value substitute here. Then 1 by 12186.33. Then its total value 0.000820059 centimeters. Centimeter inverse becomes to centimeter. Therefore lambda is equal to 8205.9 into 10 power minus 8 centimeter inverse. Then here 1 2 3 4 5 6 7 8. So here 8205 point here here put here point after 5. Here 8 digits after we put the point. That's why 10 power minus 8 centimeter. 10 power 8 centimeter is becomes to 1 angstrom. 1 angstrom equal 10 power minus 8 centimeter equal. Therefore 8205.9 angstrom, or it is approximately equal to 8206 angstroms. The option is the wavelength of limiting line of Paschen series is 8206 angstrom units. So that is the seventh one question. Option is 3. Then next see the eighth one question. The excited hydrogen atom returned to ground state. The wavelength of emitted photon is lambda. Principal quantum number of excited state is, once again read the question. The excited hydrogen atom returned to the ground state. So this is the excited state electron, ground to the return back to the ground state. The wavelength of emitted photon. So this emitted photon wavelength is lambda. Principal quantum number of excited state. What is your excited state? It may be n is equal to 2 or n is equal to 3 or n is equal to 4. It may be de-excited from second orbit to first orbit, or third orbit to first orbit, or fourth orbit to first orbit. So what is your n value? We have to find out that one. Your electron jump from which orbit to which orbit? What is the excited state of principal quantum number? That is the question. Then see the here 1 by lambda is equal to r into 1 by n1 square minus 1 by n2 square. Here 1 by lambda is equal to r into here excited state to first orbit. Then n1 value is 1. So 1 by 1 minus 1 by n2 square. We don't know n2 value. That is we have to find out. Here n2 is excited state principal quantum number. Here n2 is a excited state principal quantum number. Then see here 1 by lambda is equal to r is there. Then r into lambda. Then 1 by r lambda is equal to 1 minus 1 by n2 square. Then next one is here 1 by r lambda comes to this one side. 1 by n2 square is comes to this one side. It is shifted to this one side. It is shifted to this one side. Then 1 by n2 square is equal to 1 minus 1 by lambda r or r lambda. Then 1 by n2 square is equal to, then we get the cross multiplication value. Then lambda r lambda r into 1 lambda r minus 1 divided by lambda r. Then this is 1 by n2 square value, this value. If n2 square value, we get the volta value. That means lambda r divided by lambda r minus 1. Then n2 is equal to n2 square value this one. Then n2 is equal to lambda r divided by lambda r minus 1. Your square is becomes to power 1 by 2. That's a lambda r divided by lambda r minus 1 power 1 by 2. So that is the n2 value. Lambda r divided by lambda r minus 1 power 1 by 2. So this is the principal quantum number for the excited state. Option is lambda r divided by lambda r minus 1 power 1 by 2. The next one question is question number 9. An electron in hydrogen atom makes transition from a state in which its de Broglie wavelength is lambda 1 to state where its de Broglie wavelength is lambda 2. The wavelength of photon is lambda. Generated will be. Once again read the question. The electron in the hydrogen-like atom makes transition from the state. So electron transition from this one orbit to one orbit. But first orbit, higher orbit wavelength is here lambda 1. The state where its de Broglie wavelength, this is lambda 2. The wavelength of photon, here photon wavelength is lambda. Okay. Wavelength of photon lambda generate value. What is your lambda value? We have to find out. Then see the question number 9. Once observe here question number 9. So lambda value formula, wavelength and energy relation, wavelength and kinetic energy relation. Wavelength lambda is equal to h by under root of 2me. Lambda is equal to h divided by under root of 2m under root of e. So we are separating the under root value, under root 2m under root of e. Then e is comes to this one side, under root e is comes to this one side, e is come to this one side, lambda comes to this one side. Then under root e is equal to h by under root of 2m into lambda. So this is lambda. Then both side we are multiplied, we are taking the square. Here under root e square, here also we are taking square. Square ki root cancel, then we get the e value. Here also square ki, here also root cancel, then h square and lambda square 2m lambda square will come. Then e is equal to h by 2m lambda square. Then energy of first orbit E1 is equal to h by 2m lambda 1 square. Higher orbit E2 is equal to h by 2m lambda 2 square. Change in energy on transition from lambda 1 to lambda 2. Therefore, means this is the lambda 1 to, this is the lambda 2. This is lambda 1, this one lambda 2. Then change in energy on transition from lambda 1 to lambda 2. Then E1, this is E1, this is E2. E1 from E2. Then it becomes to h square by, then substitute the, instead in the place of E1 we have to write h square by 2m lambda 1. In the place of E2 we have to write h square by 2m lambda 2. Then we write here h square by 2m lambda 1 square minus h square by 2m lambda 2 square. Here common value h square by 2m is common value. We take the common value, then 1 by lambda 1 square minus 1 by lambda 2 square. Okay. Then we get the here cross multiplication. Then lambda e is equal to h by 2m into lambda 2 square minus lambda 1 square divided by lambda 1 square into lambda 2 square. Then here delta e is nothing but hc by lambda, means is here. So delta is equal to hc by lambda, is here, this is hc by lambda. Then h square by 2m into lambda 2 square minus lambda 1 square divided by lambda 1 square into lambda 2 square. So here hc is comes to this one side, then 1 by lambda is equal to h square by 2m hc. Here h square cancel, the remaining lambda 2 square minus lambda 1 square divided by lambda 1 square into lambda 2 square. Then 1 by lambda value h by, after cancelling the h and square value, then h by 2mc. 1 by lambda is equal to h by 2mc into lambda 2 square minus lambda 1 square divided by lambda 1 square into lambda 2 square. Then this is 1 by lambda. Then what is lambda value? Lambda is equal to h by 2mc na, it becomes to 2mc h becomes to here, it value will come the ulta value, that means an opposite value. Then lambda 1 square into lambda 2 square divided by lambda 2 square minus lambda 1 square. So this is the wavelength of photon. So this is the lambda value. Once again here lambda is equal to 2mc by h. Lambda 1 square, lambda 2 square divided by lambda 2 square minus 1 square. That is lambda value. See here lambda 2mc by h into lambda 1 square, lambda 2 square divided by lambda 1 square minus 2 square. So your option is 4. Your option is 4. So this is the question number 9. Then see the question number 10. The time period of wave is 5 into 10 power minus 3 second. What is its frequency? The given time period, we have to find out frequency. Frequency is equal to 1 by t formula. Okay, then 1 by here time period, 1 by 5 into 10 power minus 3 right here. Then what will get? 1 by 5 into 10 power minus 3, 0.2 into 10 power minus 3, 10 power plus 3, then 2 into 10 power 2. So frequency is 2 into 10 power 2 second inverse. Two into 10 power 2 second inverse. So this is the option. The next one is the question number 11. The photo electrons are liberated by the UV light. Wavelength is 3000 angstrom from metal surface, for which threshold wavelength is 6000 angstrom. De Broglie wavelength of electron emitted with maximum kinetic energy. So this is the metal surface. So this is incident light wavelength is 3000 angstrom units. So this incident light have the energy packets are quanta. This quanta is transfer the 6000 angstrom energy to the metal atom. 6000 angstrom energy to the metal atom. Then the electrons are emitted. The emitted electrons kinetic energy is emitted electron kinetic energy we have to find out. That is maximum kinetic energy of electron. Then see here question number 11. Once here question number 11, E is equal to, see here, E is equal to W plus K. Total energy is equal to work function plus kinetic energy. Your lambda value 3000 angstrom units into that angstrom is becomes to meters. So 3000 into 10 power minus 10 meter. Then energy. First of all, this is energy. Energy is equal to SC by lambda. H value we know Planck's constant to 6.6 into 10 power minus 34 joule seconds into light velocity we know 3 into 10 power 8 meter second hours divided by your lambda value incident light wavelength 3000 meters, 3000 into 10 power minus 10 meter. Then we calculate total value, we will get 6.6 into 10 power minus 19 joules. But work function is nothing but W is nothing but C by lambda naught. Okay. Then again you substitute this is energy of incident light. Then energy of threshold frequency. See here, energy of work function. W equal to SC by lambda na. Then what about the W value? SC by lambda means 6.6 into 10 power minus 34 into C value light velocity divided by lambda naught value they gave already in problem 6000 angstrom units. 6000 into 10 power minus 10 angstroms converted into meters. Then we calculate the total value. We'll get a work function value 3.3 into 10 power minus 19 joules. So this is energy of incident light. This is energy of threshold frequency. Okay. The next one is from this formula E is equal to W plus K na here. So from this one Ke separated me. You have to separate Ke. Ke means E minus W na. Therefore E minus W. Therefore K is equal to E value 6.6 in 10 power minus 19 minus W value 3. This is E value, this is W value. W value 3.3 10 power minus 19 minus 19 10 power minus 19 common value. Then remaining 6.6 minus 3.3. 3.3 into 10 power minus 19 joule. This is kinetic energy. That is kinetic energy. Then next one is to this kinetic energy, that kinetic energy changed to the wavelength. Then wavelength kinetic energy relation lambda is equal to H by under root of 2 KEM formula. Then H is equal lambda is equal to H by This is lambda is equal to h by means h value 6.6 10 power minus 34 joule second under root of 2 into kinetic energy means here already we got 3.3 into 10 power minus 19 kinetic energy. Okay, then next one is so this is the kinetic energy we got already. Then next one is m value. M value means electron mass 9.1 into 10 power minus 31 kilograms. Then its total calculated value 2 into 3.3 into 9.1 60.06 into 10 power minus 90 10 power minus 31 10 power 50. To take the root of 60.60 into 10 power minus 50, its value 7.749 into 10 power 25. Then 6.16 power minus 34 divided by 7.74 into 10 power minus 25. We calculated that value 0.851 into 10 power minus 9. Or a point changed here 1 digit to 8.51 into 10 power minus 10 meter. That is kinetic energy wavelength. Emitted electron kinetic energy wavelength 8.51 into 10 power minus 10 meter. Here 8.5 into 10 power minus 10 meter. So this is kinetic energy wavelength. This emitted electron kinetic energy is wavelength we calculate 8.5 into 10 power minus 10 meter. Option is 2. Then next one is question number 12. Uncertainty in the velocity of two particles A and B. This is uncertainty in the velocity. This means this value is delta VA. This is delta VB. The mass of B 5 times then mass of A means mass of A MA is equal to 1, MB is equal to 5. What is the ratio of delta XA divided by delta XB in their position? Then see very simple question. Then see the question number 12 here. XA into delta XA into MA delta VA equal delta XB into MB delta VB. Delta XA into mass of A is 1 into delta VA they given 0.05. The next one is delta XB ratio we have to find out. MB mass of B is 5 times then A into uncertainty in the velocity they given for B 0.02. Okay, so 0.02. Then see here, so this is the MA delta VA, MB delta VB. Then delta XA divided by delta XB. Delta XA this one, delta XB comes to this one side. Then M delta V comes to this one side. Means MB delta VB divided by MA delta VA. Delta XA divided by delta XB. So delta XA divided by delta XB is equal to MB delta V divided by MA delta VA. So here MB delta VB means 5 into 0.02 divided by 1 into 0.5 this value. Total 0.1 divided by 0.05 its value total. The ratio of delta XA divided by delta XB is 2. So here its ratio is 2. Its ratio is 2. Option is 2. The next one is question number 30. The product of uncertainty in the position and velocity for a electron in meter square by seconds. Uncertainty in the position and velocity meter square by seconds. What is uncertainty in the position and velocity? That means delta x into delta v value we have to find out. Means actual formula delta x into m delta v is equal to or greater than equal to h by 4 pi na. Then delta x into delta v divided by h by 4 pi m. So that is formula. By using this formula we have to calculate delta x into delta v product 2. Then substitute that value h value Planck's constant 4 into pi value we know. M means velocity or mass of electron. Then mass of electron already I told 9.1 into 10 power minus 31 kilogram. Then substitute that value you will get very easy answer. Sir, delta x into delta v is equal to h by 4 pi m. Then h value 6.6 10 power minus 34 kilogram meter square second inverse. 4 into pi value 3.14. Mass of electron 9.1 10 power minus 31 kilogram. Its total calculated that one 4 in the total value calculated, then we get 0.0577 into 10 power 3 meter square second inverse. So point change it here 2 digits, then 5.77 into 10 power 5 meter square second inverse. 5.77 into 10 power 5 minus 5. 10 power minus 5. Yeah. 5.77 10 power minus 5. See here, this is 5.77 or 5.8 approximately into 10 power minus 5 meter square second inverse. So this is the correct option for that question. Okay. Then next one is the kinetic energy of a particle is doubled. Kinetic energy is doubled. The de Broglie wavelength will become. So this is 14th question. See here 14th question. Sir, kinetic energy and wavelength relation. Already I gave this equation formula also. Kinetic energy wavelength relation lambda is equal to h by under root of 2 into kinetic energy into m. So by using this one formula, here h is constant, mass of electron also constant, then lambda proportional to 1 by 2 also constant, 1 by ke under root of ke. Then lambda 1 by lambda 2 is equal to under root of k2 divided by k1, ke1, ke2 divided by ke1. Then lambda 1 by lambda 2 is equal to ke2 is doubled, kinetic energy is doubled na, then root of 2 by 1. Then lambda 1 by lambda 2 is equal to under root of 2 divided by root of 1 means its value 1. Therefore lambda 1 divided by cross multiplication. Then lambda 1 into 1 equal to so lambda 2 is comes to this one side, then root 2 is comes to this one side. Lambda 1 by root 2 is equal to lambda 2. Then lambda 1 by root 2 means it can be written as 1 by root 2 into lambda 1 equal to lambda 2. Your wavelength how much changes? 1 by root 2 times changes. Then answer is 1 by root 2 times. That is the question number 14. 1 by root 2 times. Wavelength will becomes to 1 by root 2 times changes. Then next one is question number 15. See here, if electron is accelerated by the potential difference of 300 V, then wavelength associated with moving electron will be. So potential difference they given 300 V. Wavelength you have to find out. Then wavelength and potential difference relation. See here formula. See here. So this is the formula. Wavelength potential difference. So lambda is equal to 12.27 divided by root V. Root V means change in potential difference. That is in angstrom units. Then substitute that value. We will get very easy calculation. Then 12.27 divided by root V means change in potential energy 300. Then angstrom. Then root 300 value 17.32. Then 12.27 divided by 17.32 will get 0.708 angstrom units. That is answer. 0.708 angstrom units. Here 0.708 or 0.707 angstrom. This is the answer for this question. Okay. Then next question number 16. Let the mass of the particle will be 1 gram. 1 gram is changed to 1 kilogram. 1 gram equal to 10 power minus 3 kilogram. Then wavelength, de Broglie wavelength they given. This is lambda value they given, mass they given. You have to find out velocity. That means lambda is equal to h by mv na. Then v is equal to h by m lambda formula. Okay. Then what we get? Question number 16. Here. Lambda is equal to h by mv, v is equal to h by m lambda. V is equal to h value 6.63 10 power minus 34 Planck's constant divided by mass of electron 1 gram is becomes to 1 kilogram 10 power minus 3 kilogram. Lambda value they give 6.63 into 10 power minus 33. Here mass meter square ki cancel, kilogram cancel, then remaining meter second inverse 6.63 cancel, remaining 10 power minus 3 10 power minus 33 10 power minus 36 10 power minus 34, then it becomes total 10 power 2 meter second inverse. It means 100 meter second inverse. Answer is 100 meter second inverse. The obtained answer is 100 meter second inverse. So that is the velocity. The next one is the de Broglie wavelength of electron having kinetic energy. This is kinetic energy. This is wavelength. What is the your A value? A value means your wavelength something into 10 power minus 8 meter. What is your something x value? You have to find out the wavelength by using the kinetic energy. So already I told wavelength kinetic energy formula. Okay, lambda is equal to h by under root of 2 me. Me means this is kinetic energy. Then lambda is equal to h value 6.6 into 10 power minus 34 under root of 2 into m means mass of electron 9.1 in 10 power minus 31 into kinetic energy 2 points they given in test they given in question kinetic energy 2.7 into 10 power minus 23. Then you calculate the total value 2 into 9.1 into 2.7, its value 49.14 into 10 power minus 31 and 23, its value 54. The root of 49.14 into 10 power minus 54, its value 7 into 10 power minus 27. Then 6.6 divided by 7, its value 0.94 into its total value 10 power minus 7. 10 power minus 7. Point change it here 1 digit to 9.4 into 10 power minus 8 meter. Here what is your A? Here in question what they given? Wavelength A into 10 power minus 8 meter. Here what is A value? A value is 9.4. So here A value is 9.4. That is question number 17. 9.4. So this is A value 9.4. Option is 2. Then next one is the question number 18. The de Broglie wavelength of electron traveling at x percentage of the speed of light was found to be 2.42 angstrom units. Then what is your x? Means here they given wavelength 2.42 angstrom, that is converted into meters is here. Here they given wavelength. From this one we have to calculate the velocity. After the velocity is taken in the percentage. Sir, wavelength they given 2.42 angstrom, that is changed to the meter. 2.42 into 10 power minus 10 meter. Mass of electron we know 9.1 in 10 power minus 31. H value we know 6.6 10 power minus 34 joule second. Then lambda is equal to h by mv. V is equal to velocity h by m lambda. And then substitute that value, h value, m value, v value in this equation. These three values substitute here. H, m, v, h value, m value, lambda value substitute here. 6.6 10 power minus 34. M value 9.1 10 power minus 31. Lambda value 2.42 into 10 power minus 10 meter. Then calculate its value 6.6 divided by its total 9.1 2.42, its value 21.84. They calculate this total value, then we get 0.302 into 10 power this total calculation minus 34 10 power minus 41, its value 10 power 7. Okay, this is 10 power 7. Then 0.302 into 10 power 7. Your point change it here 1 digit to 3.02 into, means your point change it here 1 digit to 3.02 into 10 power 6 meter second watts. So this is velocity. That velocity taken in the percentage means normal light velocity 3 into 10 power 8, but here obtained velocity is 3 into 10 power 6. 3 into 10 power 6 divided by 3 into 10 power 8 into 100. Then how much we got? 3 cancel. 10 power 6 here, 10 power 8. Then remaining 10 power 2 is pending. 10 power 2 means 100. 100 cancel means only 1%. The speed is 1%. So option is how much change in the speed means the percentage of the speed of light is x is 1%. Option is 1%. Then question number 19. The maximum number of electrons in the d orbital is x. Minimum number of electrons of same spin in the d subshell is y. What is x plus y? Very simple question. Maximum number of electrons in the d orbital, not orbitals, d orbital. D orbital maximum 2 electrons can accommodate. Here, maximum number of electrons in the d orbital 2 electrons. Each orbital can accommodate maximum 2 electrons. So x value is 2. Minimum number of electrons, same spin. Minimum how many electrons? These 2 electrons. Here 2 electrons is there in one orbital. This electron get excited state. Again this electron jumped from first orbit to second orbit. So here 1 electron. Second electron is transferred to the second orbit. Here. So minimum 2 electrons have the same spin. Minimum 2 electrons have same spin. Here 2 electron, here 2 electrons. Y value 2, x value 2. Total 2 into 2 plus 2 or 2 into total 4. So its value is not 2 into 2 into the 2 into 2 4. Then option is question number 19. Option is 4. So x and y is 4. Then last one question number 20. The ratio between kinetic energy and total energy of electron of hydrogen atom according to Bohr's theory. So this is important model. So the ratio between potential energy and kinetic energy and total energy. Here the ratio of potential energy, kinetic energy, total energy ratio. Potential energy is -2, kinetic energy is 1, total energy is -1. But question what they know, the ratio of kinetic energy total means these two only they asked. Kinetic energy is 1, potential energy is ratio -1. So 1:1 ratio. The ratio of kinetic energy and total energy of hydrogen atom in which electron present in this Bohr orbit 1:1 ratio. So option is 1:1 ratio. So this formula is important. 1:1 ratio. So this is the ratio of kinetic energy and total energy 1:1 ratio. So this is about the atomic structure